Hi everyone, welcome back to the channel. In this video, I will be demonstrating an AI-powered system that automatically converts meeting recording into the structured Jira tickets. This project is built as a production-style application focusing on real-world architecture and scalability. So, what does this system do? You provide a meeting recording and either from the YouTube or Zoom meetings. The system extracts the audio, transcribes it using AI, generates a summary, identifies action items, and allow you to create Jira tickets with one click. Everything runs asynchronously, just like a real production system. Before I continue, I want to quickly clarify one important limitation here. So, Zoom recording cannot be accessed directly using the Zoom link unless the application is authenticated with the Zoom or OAuth and has the proper permissions. Okay, and so, since this project is focused on the AI workflow and backend architecture and not the Zoom authentication flows. Okay, so I have used the recorded Zoom meetings that was downloaded and uploaded to the YouTube for demo purpose. This allows the system to process real meeting audio, demonstrate the transcripts, and generate Jira tickets without being blocked by Zoom authentication requirement. Yeah. And but in a production setup, this can easily be extended using the Zoom or Zoom Webhook or a Zoom Cloud Recording APIs. Let me briefly explain the architecture. The front end is built using the Streamlit UI. The backend uses the FastAPI, and jobs are pushed to the AWS SQS, and background worker service process them. The worker download the audio, transcribe it using the Whisper, send it to an LLM, and store structured result in the database. So Jira ticket creation is handled using the Jira REST API. Now let's see the system in action. I will paste the meeting link here. Let me, I have already one meeting here. This is Zoom recording I have downloaded from the Zoom account and uploaded to the YouTube. I will select the source as the YouTube, okay, and process meeting. The job is now sent to the backend and queued for the processing. Okay. So behind the scene, a worker picks up the job. It downloads the audio, transcribe it, and send the transcript to an AI model. The AI generate a meeting summary, decisions, and structure action items. All of this happens asynchronously and without blocking the UI. Once process is complete, the UI update automatically. Okay, and here you can see the meeting summary, decision taken, and the action item extracted from the decisions. Yeah, so this is summary from the meeting that audio uploaded from the link. This is a decision. What is the decision taken in the meeting? And these are the action items. Now I will select the few action item. Okay, and just click the create Jira tickets. The backend calls Jira REST API and creates the real Jira issues. You can see the, yeah, so Jira ticket created. See the generated ticket links here with the name. Okay, so here you can check those 4 Jira got created. And these are the actual Jira ticket created from the meeting discussion. Okay, you can click here and let me check if I can show you here. Yeah, this is actually got created in the Jira. So yeah, regarding the job history, the system also maintain the complete job history. Each job stores the summary, decisions, action items, and the what are the Jira ticket we have added. The data is persisted in the database and available even after the refresh. You can try the refresh here. So it's a job history is here. So some key technical highlights of these projects are asynchronous job processing, background worker architecture, then clean separation of the UI and the backend, no blocking operation, scalable design, and real Jira integration. This setup closely resembles the real-world enterprise workflows. So this project demonstrates how AI can be used to automate meeting workflows and reduce the manual effort. It designed to be extensible with support for the Zoom authentication, cloud deployment, and the enterprise scaling. Thanks for watching. If you found this useful, please feel to check out the GitHub repository or connect with me on the LinkedIn. I will be sharing the details GitHub link in the YouTube video descriptions. Thank you.